When you think about people who have good immunity, what first comes into your mind? You might reasonably think they never get sick, and to some degree, you're right. The people who might possess this characteristic come in all shapes and sizes, tall, short, red, or blue. The concept of immunity is both unique to each one of us and transcendent between us. You have a tiny army inside of you. It's no conspiracy. They may not be little green men, but they are white blood cells, and you are their captain, their commander-in-chief. As the commander-in-chief, you yourself facilitate the conditions your army persists in. Sometimes you can't help it. It's something constitutional, something innate or genetic that holds back your army. Sometimes it's a consequence of where you work and live. Other times it's your behaviors, whether that be smoking, poor hygiene, or poor diet. This can mean the difference of whether you bounce back after getting sick, or maybe you're one of those who are frequently ill. So it might lead you to think, more colds, more often? To begin to answer that, we need to start attaching a name to the faces of your army. Just exactly who makes up this army that you've been put in charge of command. But as a preface, there are two arms of immunity, innate and adaptive, at times separate but by no means independent. They correspond with each other. When we look at it, your body is the interface of an internal system in relation to the environment. In that environment are pathogens, the agents which can get you sick. So let's begin with innate immunity. Innate immunity consists of mechanical barriers to infection, like skin and mucosa. The skin being a physical barrier, the mucosa being a chemical barrier. But right now, think of them as more like a barricade in the front line of your health and well-being. But, wait, who's poking their head out of the foxhole? They're behind your lines of defense. Could they be enemies or friends? Actually, it is here we meet some of the frontline defense. The macrophage, the mast cell, and the natural killer. Today for this video, we focus on the big guy, the macrophage. Hopefully, we'll get to know the mast cell and the natural killer cells in a future video. Maybe we'll even meet the neutrophil, the basophil, and the eosinophil, too, in the future. But, back on point, the big guy, the macrophage. Let's do a meet and greet. Macro, meaning he likes to eat big meals. Phage roughly translates to eat. Pathogens like bacterium are precisely what he likes to eat. Like you and me, after he encounters a nice hot meal, he doesn't just eat blindly. As we should know, cells don't have eyes like you and me, but by no means are they flying blind. He's also rather picky. He wants something specific, and obviously he has a way of discerning what he likes and what he doesn't like. Using a repertoire of complexes, he visualizes the pathogen. One of the many mechanisms he uses to visualize the pathogen are toll-like receptor heterodimers, TLRs for short. So if you ever read up on a study on this big guy, you're bound to see TLRs in some form. So after attaining a visual, right then and there he engulfs it via endocytosis. But then he wants to tell all of his friends about it, especially when there's a lot of them, or if there's a particularly unique one. Right after he eats the pathogen, he starts sending the signal out as chemotactic cytokine, sending the word out to other cells, both immune or not. Meanwhile, the meal he just ate is encountering the macrophage's stomach, so to speak, an endosomal lysosome. Going past the complexities of respiratory bursts and the complement system, the pathogen is, for all intensive purposes, digested into special fragments, called antigens. Now, I'm speaking to you in English, hopefully. And you could say that cells talk to each other, but the language is not always one universal language. In reality, many cells must be multilingual. So one major point that I need to make is that the macrophage is of a class of cells called antigen-presenting cells. Now, we have to determine what an antigen really is, and it's an element which elicits antibody generation. Sometimes we call it AG for short, and for antibody generator, antigen. It is particularly important for this special language needed. And that's where major histocompatibility complexes come in, MHCs for short. MHCs are how the big guy can grab the attention of the lieutenants and captains of your army. the facets of adaptive immunity, the T cell. The frustration and the elegance of these cells are the fact that they sort of talk in a very specific language, a very sophisticated mode of speech. Sometimes you have to show them something particularly striking to pique their interest. That particularly striking thing that piques their interest is that digested fragments that we referred to before, the antigens. In a sense, this is how antigens are presented to the chin-up sophisticated one-language-only T cell, who then talks to the B cell, who then creates the very much needed antibody, which is a facet for your immunity. Or, alternatively, it's an induction of the complement pathway to help our big guy, the macrophage, better see the same antigen again. Then you need to factor in how specifically our B and T cells craft their little esoteric languages, which enters us into a discussion of TCRs, T cell receptors, and BCRs, B cell receptors. Mind you, the language are not signals in the air, rather they're specific biochemical elements coming from biochemical cascades. So as you can tell, it gets very complicated very quickly. And that is just barely scratching the surface of immunology. But if being sick can incapacitate you, and in the worst case scenario kill you, as the commander-in-chief, it is your responsibility to consider those who fight for you. Getting to know their names and what they do is always a good start. Welcome back. Remember when I told you about the macrophage and how some immunological processes seem to revolve around eating and talking? Well, I lied. Partially. I really just oversimplified it. In general, the immune system is really more like one big alert system, a reactionary system. After all, it is trying to keep the status quo within your body. Let's say you saw your greatest fear, spiders, snakes, student loans, you name it. You might be induced into a reaction, and that's perfectly okay, if you know how to, or if you let yourself balance it out. In fact, to some degree, your immunity works the very same way. So here's the normal. You encounter something you think is a danger, you react, then you relax. No net harm done. Here's autoimmunity. You encounter the danger, you react, then you panic, then you end up hurting yourself. And here's the topic of the day. Immunosuppression. You see the danger, but you don't react. But then you might generalize that reticence. Then something bad comes through the woodwork, and something particularly debilitating or an opportunistic pathogen makes its way in, because the defenses have been put down. Today we'll talk about one instance of immunosuppression, and we'll refer back to our good friend, the big guy, the macrophage. But this is a special type of macrophage. Our big guy today lives in a structure called the alveolus, a 1-micron thick sac which governs gas exchange in your body. Our friend today's name is the alveolar macrophage, the AM for short. Now it's time to paint the picture by creating a context. Tobacco smoking. It is a persistent and prevalent issue in today's society. In the US, the issue has been with us ever since Dolan Hill's seminal study of physician smoking. Before that, it was Lucky Strikes and Marlboro that was funding your news and building your playgrounds. Now we recognize smoking as a significant risk factor. Now we have effective and widespread programs to minimize the impacts of tobacco smoking, from the 5 A's of smoking cessation programs all the way to legislation banning smoking indoors. It goes to show we've had some success in tackling smoking. So it might be tempting, if not natural, to think the U.S. has conquered smoking in a way. But I would argue that the immunological points of this issue have been more or less neglected from the public eye. But that raises the question of, what does smoking have to do with the finer points of immunity? If you remember, smoking's most publicized component is the addictive nicotine. And when you inhale tobacco smoke, the first immunological component encountered will be those in the alveolus. Remember our friend the AM? His guard post is right there. He's doing the very same thing we learned when we first met him. It's important to consider that nicotine is not only addictive, it's an endotoxin. Remember that immunosuppression is due in part to a state of non-reaction. In a more scientific context, this final condition is a synergy of something called hyporesponsiveness, meaning subpar or below effective response, coupled with something called T-cell anergy. Specifically, nicotine itself rides on a pre-existing antigen to create a complex, the nicotine antigen complex. Remember antigens, antibody generators? Let's add a further specification on that. Antigens are elements which induce reaction in the adaptive immunity. Normally, your AM would react to pass on the message of danger to T cells. But because you, the commander-in-chief, deem that you need nicotine, eventually the AM will be induced to not reacting as it should. After all, the commander-in-chief is ordering a no-response protocol, and that commander-in-chief does control everything. You might think, wow, that is some power you have. Really feeling like the master now, the general, like you have control over your body with the power of your mind? Well, unfortunately for you, there's a residual. Remember, for macrophages to see, there is that dialogue going on between it and all of their cells. Well, sometimes, in the process of being hyporesponsive, the AM needs to change itself so that it begins to tolerate the nicotine we're flooding into the body. In changing the AM, you have changed the way that it talks to the T cell, which induces its relative hyporesponsive equivalent, which we know as T cell anergy. Now, the T cell itself refuses to react when it should. Keep in mind that these changes are genetic. Messing with the functional parts of the genome to accommodate for nicotine tolerance has the potential to change things without your knowledge. A runoff, if you will, a cascade of events, or in this case, a series of unfortunate events. What we eventually see is an effective cessation of responses to nicotine in our body. The endotoxin has been effectively tolerated. What we don't see until it is clinical, and what is often the most damning cases for heavy or chronic smokers, is when there is an incidence of an infection our good friends the AM or the T cell should have easily caught had our responses been normal. It is through this unique lens of immunology that we can fully appreciate the more systemic complications our behaviors induce. In elucidating the intricacies our personal bodily army has, and considering the functions some white blood cells have, like acting as sentinels or executives, I hope that we can gain a little more insight that extends beyond simply seeing the vivid and grotesque blackness from the tar of a smoker's lungs, or waiting for biopsies of our own lungs and turning up malignant. I also hope that in consideration of the immunological point of view, one's own health ceases to be something isolated. The conditions for this behavioral and artificial forms of susceptibility to these secondary and opportunistic pathogens can be mitigated if we see risk factors like smoking from newer lenses. Ladies and gentlemen, one final word. If you choose to smoke, you are conditioning the gatekeepers of your body, the AM in the alveolus and the T cell systemic to your whole body, to become weak. They're bored, they're lethargic, and now negligent, reticent to react, reacting only when things really hit the fan. But you cannot fault them. The administration above them, the larger body that has jurisdiction over them, is now placating them. And it is only a matter of time until either the floodgates break or the most damning thing seeps through the cracks.